So now let's look into vectors. In MATLAB, we have matrices. In MATLAB, MAT stands for matrix, matrix laboratory. Um, so in MATLAB, we have matrices and vectors. Matrices, of course, we discussed them in LabVIEW. Um, the arrangement of data in two-dimension or three-dimension rows and columns, and in three-dimension, of course, you have rows and columns in one dimension, and then you have multiple dimensions with rows and columns. In MATLAB, you have matrices like rows and columns, and then you can have multi-dimensional matrices. And vectors is a subset of matrix. That is, if your matrix has either only one column or one row, then it is called a vector. Vectors are extremely important in MATLAB as matrices are very important. So let's concentrate on vectors in this lecture. Vectors, how do you define vectors? As I said, only one row or one column. So let's say if I want to define a vector A, it is going to be, let's say, 1, 2, 3, 4, 9, 2.3, all this. That's a vector. So you define the vectors using square brackets. And either you leave a space between each entity of the vector, or you can put a comma. So you can do 4, comma 6, comma 9, comma 10, whatever. So that is also a valid way of defining a vector. These are row vectors because it has only one row, multiple columns, one row. How do you find the size of a matrix or size of a vector? By using size function. So if I do size of A is a vector, as you can see, it's going to show me 1, 5. That is, it has one row and 5 columns. So size is a function that is used to determine the size of a matrix or a vector. If you just want to find out length of a vector, because vector has only one row, so how many elements are there? One row or one column, sorry. So how many elements are there? So you can use length function, length of B, for example, 4. So these are A and B are row vector, one row. You can also define column vector, which has one column. So let's say C is column vector 1, and to enter into a new row, you have to put semicolon. 5, 7, 9, 23.4, so on and so forth. So if you put a semicolon, that's gonna define that's gonna start a new row. So it's a column vector now. It has one column and 5 rows. So if you want to check the size of C, 5 rows, the first one is rows, and one column, second one is column. And now again, the next topic is going to be matrices. But again, matrices are extension of vectors. So for example, if I want to define a matrix, two-dimensional matrix, D, 1, 3, 4, 5, that's my one row. 6, 7, 10, that's my second. So now I have 2 rows, 3 columns. 2 rows and 3 columns. And if you want to check out the length of a matrix, basically, it's going to show you the length of each column. So length of D is 3. That is the length of each, it's going to show you the length of the largest dimension, not the column, sorry. Length of the largest dimension. So if the rows are larger than columns, then it's going to show you that length. So length is not a very good function to use with matrices, but it's an excellent function to use with vectors, because vector has only either one column or one row, and then length will determine what are the number of component in that one column or one row. And if you want to know if it's a row vector or a column vector, then you can use the size function. You can convert a row column into a row vector into a column vector, and vice versa, by taking the transpose of the vector. So for example, my vector A is this that I defined earlier. If I take the transpose of a vector, I just have to use apostrophe, A apostrophe. That will take the transpose of the vector. and it's going to convert it into a column vector. Now I'm not assigning it to any other vector, but if you want to assign that, let's say G is equal to A transpose, then G will become a column vector, which has the same numbers in this case as the vector row vector A. So these are vectors. This is how you define vectors in squared brackets. Now sometime, for example, if you are evaluating a function and you have values of time or values of x or whatever variable that the function depends upon in an orderly fashion. For example, if you're plotting a graph and you are plotting a graph of a function, let's say 2x squared, a quadratic function, and you are plotting it from x is equal to -10 to 10, and you want the interval to be 0.1. So you can define that as a function without writing all the values. Of course, that's going to be too many values, from -10 to 10 with an interval of 0.1. So, -9.9, -9.8, all the way up to +10. So you're not going to type all those values. So in those cases where you have to define a big vector and you have some sort of interval between the values, a constant interval between the values, then you can also define the vector as, let's say, f. I want to start at -10. I want the interval to be 0.1, and my final value will be 10. So you can write the vector like this: -10 colon 0.1 colon 10, and it is going to define 201 values from -10, -9.9, all the way up to 10, 9.9 and 10. So of course, I mean, you're not going to write all those values in the squared brackets. So this is how you can create a vector in another way using the colon notation if you have a specific interval between the values, the initial value and the final value. Now, if the interval is 1, then you don't have to give the interval at all. Actually, you just put down the initial value. Let's say I want to define a vector 20, 21, 22, 23, all the way up to 40. So 20 all the way up to 40. So you don't have to write the interval in that case. If you write it, it's not going to be it's not going to make any difference. It's not going to give you any error or anything, but it's just going to be redundant. So if your interval is 1, you don't have to write it. You just write the initial value colon the final value, and then it's going to define all the values and assign it to the variable as a vector. If you want to access any specific value from a vector, all you have to do is to write the variable of the vector, and then, well, let's say I want to access what is written on at index index 10. By the way, indexing, if you remember from LabVIEW, indexing of matrices arrays start at 0. In MATLAB, it starts at 1. So the index of 20 is 1, 21 is 2. So indexing in MATLAB starts at 1, not with 0. And then you cannot have negative indices or decimal indices. Only integer start at 1, and then 1, 2, 3, 4. So let's say if I want to know what is sitting on at index 4 of vector w, you write down w parentheses 4, and it's going to show you that it is 23, which is right here, this 23. So this is how you can access specific values that are sitting at specific indices using parentheses. If you want to change any value or delete any value or change any value in an existing vector or matrix, then all you have to do is, let's say if I want to delete the 4th index, which is 23, or I want to delete the value of 23, which is sitting at 4th index. So all I want to do is w4 equals empty matrix or empty vector. So it will delete that 23. So now the w is 20, 21, 22, and then 23 is deleted, 24. If you want to insert a value, now in this new w vector, remember in this new w vector, now w4 is 24. because 23 is deleted. So now indices are, index 1 is 20, 2 is 21, 3 is 22, 4th is 24. So 24 becomes the fourth index value for the vector W. If you want to insert a value, or not insert a value, if you want to replace a value, so let's say W5 instead of 25, you want to do 100. So all you have to do is W5 is equal to 100. And then it's going to replace W5, 25, and then replace it by 100. So this is basically what vectors are. Either they are matrices, but they have only either one column or one row. And then you can change, if you want, you can change the rows and columns using the what we call the transpose function, which is defined by an apostrophe. Okay, and the tutorial it's given size, length, and all those things. Now, why vectors are used and where they are used? The most common use of vectors in MATLAB is in graphing, where you're defining, let's say, a function x and y, and in function evaluation for multiple values, which of course lead to graphing. For example, if you have, we just evaluated equation in our last lecture, and if I go back to that equation for a minute, let's say we evaluated these two equations, fxy and fxyc. Let's say you have, and let's start with a simple equation. Let's say you have an equation, um, let's say quadratic equation. So you have f of x equals 2x squared plus 5x plus 3. Let's say we have a quadratic equation. And then you want to evaluate this expression for multiple values of x. Let's say you want to evaluate this expression for x, that x goes from -5 to 10 with an interval of 0.2. So how you're going to do that? Let me just do it in the command window. Although if you have to submit this program, this will be written in the MATLAB editor, remember that. But let me just show you in the command window. So x will be equal to, let's say we want to start the value of x at -5. We want the interval to be 0.0, 0.2. So interval 0.2, and let's say we want to go up to 10. So it's going to create a vector of x starting from -5, 0.2, and 10. And then I'm going to put a semicolon because I don't want to show this vector on the screen. And then when I'm writing the function, f is equal to, and the function is 2x squared plus 5x plus 3. 2 times x squared plus 5 times x plus 3. Normally you're going to write the function like this, right? If you are evaluating a function like we studied earlier in the last lecture, normally you're going to write the function like this. But this function is valid if x has a single value. That is what we call a scalar quantity. If x is a scalar quantity, it's not a vector quantity. Right now x is a vector quantity. It is a vector. And then you want to evaluate the equation for each entity of that vector, starting from -5, -4.8, -4.6, all the way up to 10. So you want to evaluate this expression for each value of the vector. Then this equation is not going to work. What's going to happen if I run this? Look, it's showing me the error right here. It's showing me the incorrect dimension for raising a matrix to a power. It shows you what the problem is. Check that the matrix is square and the power is a scalar. To perform element wise matrix multi-power, use what? Use this period. It tells you everything. What does it tell you? That it is assuming that since x is a vector, it is assuming that I'm trying to perform a matrix multiplication. When I'm doing the square operation, that's, a square means that I'm multiplying two values of x. So it is assuming that I'm trying to perform a matrix multiplication. but I'm not. Again, we discussed matrix multiplication in lab view, and we're going to discuss again under matrices. I don't want to go into that right now. But in any case, your idea is basically simple as that, that you want to evaluate this expression for each value of x vector. In that case, what you have to do is you write the same equation. I'm going to use my up arrow, bring the same equation. You have to use a period sign right here, this period. You have to use a period before when you're taking the power of any vector, when you're multiplying two vectors, and when you are dividing um, any vector. You're dividing either a number from a vector or a vector from a vector. Then you have to use a period before these three operations: multiplication between vectors, division of vectors, and taking power of a vector. So look at this. If I put a period over here, and then I'll execute it again, and then it's going to execute it. It's going to create another vector, because of course f will be a vector since I'm evaluating f for each value of x. So now for when x was -5, f is 28. When x was -4.8, x is 25.8, so on and so forth. So it will evaluate f for each value of x vector, and it's going to create a resultant vector. So this is the resultant vector, that is the vectors with the values evaluated from this equation or expression. So this is extremely important for you to understand. It is going to give you this error if you do not put a period before what? Multiplication of vectors, division of vectors, and power of vector. If the operation that you're performing, in that operation the variable is a vector. And that operation is called array-wise multiplication, or element-wise multiplication, as you can see over here, element-wise matrix power. So there can be the element-wise or array-wise operation. So there is a matrix operation, and there is an element-wise or array-wise operation. So let me give you another example, because I think the next example 4 is given here. You can go over it. I mean, I put multiple examples in MATLAB tutorial. Make sure to go over those examples, and not just go over those examples, do those examples in MATLAB or Octave, and then see if you get the correct results. That is, if you get the same results that I'm getting. So let me do this example real quick again. So what I'm doing here, I'm going to hide the results. What I'm doing here is I have a vector x, I have a vector y, both have the same length. When you're multiplying two vectors, taking power of any vector, especially when you're multiplying two vectors and dividing a vector from a vector, then both the vectors should have the same length, same dimension rather. So there are two vectors, and this is the equation that I have to evaluate. So although the solution is given to you, let me just do it live in front of you so that you can understand. Move it here a little bit. Okay. So I'm going to clean the screen. I'm going to clean all the variables. So let me go ahead and define x now. So my x is 2, 6, 9, 10, 5. 2, 6, 9, 10, and 5. And then my y is 4, 7, 2, 1, 9. 4, 7, 2, 1, and 9. Okay. All right. And then I'm evaluating z. And observe that x and y both are vectors. Of course, both needs to have the similar length, similar dimension. So 4x cosine of y, 4 times x. Now, when you multiply a vector by a constant value or a scalar value, what we call, you don't have to put a period before the operation, before the multiplication sign. But now when I do x times cosine of y, now cosine of y, since y is a vector, cosine of y will be a vector as well. That is, it will evaluate the cosine for each value of y, 4, 7, 2, 1, and 9, and create a vector. Now, when you multiply these two, you have to put a period before the multiplication sign. Cosine of y plus 2 times log of y. And this is the log to the base 10, of course, not the natural log. So you're going to use the MATLAB function log 10 that is given in the table, table 1 or table 2, whichever table was that. Log 2 of y, And observe again, I'm not putting any period over here because 2 is a constant value. Constant value multiplied by a vector, you don't need a period over here. Now, if you put a period over there, it's not going to make any difference. So it's still going to give you the correct result. So if you are confused where to put period and where not to put period, my advice will be, if you're doing the element-wise operation, multiplication, division, whatever, my advice will be that put period. You can put period in front of every multiplication, every division, and every power sign, and it's not going to make any difference whether you're multiplying a vector by a vector, dividing a vector by a vector, or doing the operation between a scalar and a vector quantity. It's just redundant, so I don't like to put it. But if you're confused, if you put it, it's not going to generate any error. It's still going to give you the correct answer. Now, do not put period before addition and subtraction. That's an error. So addition and subtraction of vectors, you don't put any period between them. If the vectors have the same length, then the corresponding elements will be added together and subtracted from each other. So 2 times log 10 of y times natural log of x. So now log of y and natural log of x, they are 2 vectors. So I'm going to put a period times natural log in MATLAB is given by log. Log to the base 10 is given by log 10. So natural log of x plus exponent of xy and exponent of x to the power y. So in MATLAB, exponential function is exp, exponent of xy, x times y, and before multiplication I put a period because x and y both are vector, divided by, and remember this division is only the exponent functions are dividing each other, so I'm not going to put any parentheses or anything, exp of x to the power y, x to the power y. So once again observe, and I can make it a little bigger. I'm pretty sure you can see it easily, but I can change the fonts. Right here. Okay. So observe, how did I write the equation? 4 times x period times cosine y, because again x and cosine y both will be vectors of length 5, 1 row and 5 columns, plus 2 times log 10y. Log 10 is log to the base, log of base 10 basically, period times log x, because again you have log of y and natural log of x, both are vectors since y and x are vectors, plus again there is no period before pluses, as you can see, exponent of xy, and again since x and y are multiplying together and both are vectors, exponent of x period multiply y divided by exponent. And oh, actually I made a mistake here, because both exponents are generating vectors, I have to use a period over here as well, because if I won't, then it's gonna look for the matrix multiplication, matrix division, and it may produce and it will produce an error actually. So make sure, again, if you're dividing a vector from a vector and you want to perform the element-wise operation, that is, the first element of the numerator, vector in the numerator, should be divided by the first element of the vector in the denominator, and second element and second element, so on and so forth, you have to put a period. And then when you execute it, it's going to generate the value of z. Again, observe the length. 1, 2, 3, 4, 5. You have length, the same length as x and y, because the equation is evaluated for the first set of values of x and y, 2 and 4. It generated negative 4.39. Second set, 6 and 7, generated 21.12, and so on and so forth. Right here, this is the result, which is the same result. That I got. So I think it's going to be really helpful for you, as I just did in front of you. Don't look at even you can look at the result, that's not a problem, but do the problems that are given in the examples and then match the result. If you get the correct result, that means you are on the right path. If not, then of course you will have to fix the problems. So this is a brief discussion of vectors. You can read a lot more in your tutorial. Um, and exercise 4 is based on vectors.